Hi student. So now let us move to the fresh topic, that is nothing but the composition of function. So in the previous concepts we have came across the concept like types of the function, where the type of the function which is defined upon the based upon the mapping. So upon mapping, the types of the function which we have learned was one function, another one is the onto function. So based upon this one function and onto function, we have solved many exercise problems, so where we can clearly understand which function is one and which functions are called as an onto function. So now let us come to the new concept or a fresh concept of the functions, relations and function topic, that is nothing but composition of function. So what is this composition? Composition of function means combining two or more functions. So what does the combining is representing? So combining, it does not imply adding any two or more functions or multiplying any two or more functions. Multiplying the two or more functions, it comes under the algebra of the functions. So combining two or more functions, it is not imply adding or multiplying any two or more functions. So now let us understand what is this composition of two functions or combining two or more functions. Suppose if I take a function f of x as equal to x plus 2 and function g of x is equal to what? Sin x. So now I can combine or compose the two functions, combining the function f of x and g of x in two ways. In two ways I can combine these two functions. So one is fog, another one is gof. Okay, one is fog, another one is gof. So fog, it is read as f of g of x, and gof, it is read as g of f of x. So fog f of g of x, it is nothing but f of g of x, and gof, it is nothing but g of f of x. So now f of x is equal to function x plus 2. Suppose if I take f of t, means it happens t plus 2. F of m is equal to m plus 2. Suppose f of r means r plus 2. So f of g of x means what happens? It will become g of x plus 2. So f of g of x implies g of x plus 2, because function f of x is defined as x plus 2. So what is the function g of x? It is nothing but sin x. So what happens? Sin x plus 2. So fog f of g of x, it is nothing but what? Sin x plus 2. So similarly here gof function. So g of f of x. G of x is equal to sin x. Suppose g of t means sin t. G of m means sin m. G of r means sin r. So g of f of x means what happens? Sin of f of x. So what is f of x? It is x plus 2. So it happens sin of x plus 2. So g of f of x is nothing but sin of x plus 2. So now you can clearly observe, after combining or the composition of two functions will lead us to another function, right? So it will lead us to the another function. So yet till now we have came across, if we define a function, means that function is consisting of one domain and another one is codomain. So the function is existing of one domain and codomain. So here after combining two functions, we got the another new function, that is fog or gof. So now let us understand what will be the domain and codomains of these functions. So suppose if I consider one example, that is, let f be a function which is defined from set a to b. So f is a function which is defined from set a to set b. Let the set a be 1, 2, 3, 4, and let set b be 2, 4, 6 and 8. And the function which is defined from set a to b is nothing but f, and the function is defined as 2x. So f of x is 2x means, So what will be happening with the mapping? 2 is the image of 1, 4 is the image of 2, 6 is the image of 3, and 8 is the image of 4. So this will be the mapping for the function f from a to b. Now I will define another function g, where g is a function which is defined from set b to set c. Observe here clearly and carefully. Here the domain of the function g is nothing but the codomain of the function f. When I defined the function f, the domain of that function was a and codomain was b. So when I am defining the function g here, the domain of that function is nothing but here codomain of the function f. So g is a function is defined from b to set c. So I will take the elements of the set c as 7, 9, 11 and 13. The function g from b to c, it is defined as g of x is equal to x plus 5. So clearly, what will be the elements you are taking for g of x here? The elements from the set b. So what are the elements from the set b here? 2, 4, 6, 8. So when I take the value of x is equal to 2, I am going to get 7. When I am taking 4, it is 9. When I am going to 6, it is 11. 8, it is 13. So with this mapping, one thing is clear that you observe here carefully. When I say f of x is equal to 2x, the values which are taken here for the function f of x, or when we define the function f of x, is nothing but the x values which are taken are from the set A. When I say the function g of x is equal to x plus 5, the function the values which are taken by the function g, that is x, are taken from the set B. So clearly this x and this x are different x. These both x are not the same x. Now I define a new function f of g of x, not f of g of x, sorry, GOF function g of f of x. So what is this g of f of x? I have already said how it will be going to be defined. G of f, GOF, it is nothing but g of f of x. So g of f of x, what is g of x? X plus 5. So what happens? G of f of x means f of x plus 5. So what is f of x here? F of x, it is nothing but 2x plus 5. So clearly GOF function g of f of x is equal to 2x plus 5. So now combining the two function f and g, the composition of two function f and g, we got a new function, that is GOF function, which is defined as 2x plus 5. Now let us come to know what will be the domain and codomain of this function. So here clearly a is the domain of function a, b is the codomain of function f, and b is the domain of function g, and c is the codomain of function g. So when I set a function g of f, you see here, observe clearly and concentrate clearly what I am saying right now. So g of f, GOF, it is nothing but g of f of x. So g of f of x means what? The function is defined as x plus 5. G function is defined as x plus 5. So you have written f of x plus 5. So f of x is equal to 2x. So by applying what value of x, you are going to get 2x here. Think clearly. By inputting which values of x, you are going to get 2x here. So clearly by inputting the values of the set A, if you input the values of set A, you are going to get here 2x, because if you input x is equal to 1 here, you are going to get 2, which is nothing but 2 times the inputted value, that is 2x. So clearly here you are inputting the values from the set A. So the values which are taken, inputting values or the domain of the function is nothing but the set A. Now what will be the codomain? So observe here clearly g of f of x. So f of x is nothing but what here? The set B. And g is the function which is defined from set B to C. So g of f of x means clearly f of x will be our set B and g is defined from B to C. So g of the elements from the set B means clearly the codomain. By taking the values from the set B, the function g, it is going to which set? It is going to set C. So our codomain will become the set C. So if g of f of x means the domain is the set A, codomain is the set C. So g of f of x, it is the function which is defined as 2x plus 5. So when we look into this mapping, 1 it has an image 2 and 2 it has an image 7. Like this process it will be going. So when we define or combine those two functions and when we get a new function, by combining those two functions, at that time we can directly write as a set A to C. The function is defined as GOF and the elements of the set A are 1, 2, 3, 4 and the set C are 7, 9, 11, 13 and GOF is nothing but the function is defined as 2x plus 5. So you can check it by inputting the value of set A. You are going with the function 2x plus 5. You are going to get the value this itself. For 7 is the image of 1, 9 is the image of 2, 11 is the image of 3 and 13 is the image of 4. So this is nothing but the composition of two or more function. So when I said in the beginning we are having two ways of combination or composition, that is one is fog, another one is GOF. So we talked about GOF here. So let us see what will be the fog function. So fog f of g of x. So f of g of x means it will be nothing but f of g of x. So what is our f of x? It is 2x. So f of gx means what happens? 2 times g of x. What is g of x? X plus 5. So it becomes 2 times x plus 5, which is nothing but 2x plus 10. So fog function f of g of x is nothing but 2x plus 10. We got the composition of the two functions. Now let us see what will be the domain and codomain of this function. So clearly fog means the inputting values are taken from the set G. So G is a function defined from B to C. So domain of the function f of G will be the set B. So what and all values are there in the set B? 2, 4, 6, 8. So these will be the input. Suppose if I take 2 has the value of C, means what happens? 2 into 2 plus 10, which will be equal to 14. So whether 14 is lying in either of the set? No. 14 is neither lying in A nor B nor C. So there does not exist codomain. So codomain is not existed. So when codomain only not existing means this function f of g, this composition is not possible. This composition is not possible. So when composition itself is not possible, fog, this is invalid. This is invalid. I am not saying in every cases fog is invalid. According to the what I have taken here, the fog function is invalid, but GOF function is defined. Here fog function is invalid. So clearly if I am talking regarding the definition of the composition of a function, means if f is a function from A to B and g is a function from B to C, means then the composition of these function is defined GOF from A to C, such that how the function is defined? G of f of x, which will be equal to g of f of x, where x is defined from the set for all x which is belonging to the set A, which is nothing but the domain of the function. So this is the definition of a composition of a function. suppose if I am briefing the composition of the function with the real life example which I used to give obviously while doing the function, like in the previous while explaining relations and function, how I gave one of the example of vendor machine to understand it by inputting outputting to understand the function. So I am giving here again like that type of example. So if I can take an ABC, if I consider ABC has 3 machines, if I take ABC has 3 machines means, so I'll input to the machine A some raw materials. So what and all input I am giving to the machine A, it is called as X. So after taking the raw material by the machine A, it will undergo some process. That process is nothing but the function F. So I call that process as cleaning. So what and all raw material X is there, it will undergo the process cleaning. That cleaning I called as function F. So after cleaning that raw material, you will get the cleaned raw material. So that cleaned raw material is f of x, because the function which was taken here or the process which was taken was f. So the product which we got after cleaning the raw material is f of x. So now the machine B is filled with all those cleaned raw materials, that is f of x. So from this machine which is consisting of cleaned raw material, I need that cleaned raw material into packing wise. So from machine B to machine C, the process what it is undergoing is packing. So packing all those cleaned raw material in the systematic way. So what will be the input taken by this process? So the input which are taken are clean raw material. So what and all clean raw material present in the machine B, it will be taken by the second process, packing. So it will undergo that process. So after processing of packing, what we are going to get? It is nothing but packed, cleaned raw materials. So that is G of f of x. So here we are going to get the packed, cleaned raw material. So when the packing was taking place, which was taken as input by this process? The input which was taken in this process was the elements which are present in the machine B, that is clean raw material. So this is what the mathematical function it is saying. So finally what we got? Packed, clean raw material. What we are interested in the final thing, we are inputting some raw material and the final we should get packed, clean raw material. So we are concentrated upon this one, that is G of f of x, that is we are inputting some raw material and in the final we should get packed, clean raw material. Whatever the process which is taking inside, it will be taken inside, it is not neglected. Or when I say go from A to C means here set B is not deleted. This is process which is taken inside, which we are not coming to unknown. That process will be taken inside, but we are inputting raw material. This process takes inside. Finally we are going to get packed, clean raw material, that is nothing but the function GOF. So this is nothing but a composition of 2 or more functions which can be understood in the daily life, one of the example. So to understand it, I have given one of the general example. Suppose if you didn't get this example means leave it. If you followed this only means understand this and go with the further thing. Suppose if you are not following means please go back, understand step by step each thing what I am explaining here, domain, codomain, what and all those things, it should be already cleared for you in the previous thing itself. Suppose if yet till now you are not at all cleared with what is domain, what is codomain, what is the image of the function means, then it is very hard to understand this. So before understanding this, you should understand what is domain of the function, what is codomain, what is image, what is range of the function. These things should be understood. So when you come to understand all these things, then composition of a function is not a big thing. So understand each and everything step by step, then come to the next concept. So now let us understand those compositions step by step. So here one of the example question they have given. They have defined a function f from one set to another, and they have defined the function g from one set to another, and they have given some of the values for the function f and function g, and they asked us to find GOF, that is g of f. So g of f of x, as I said, g of f of x, it is nothing but g of f of x. Now look here, observe here clearly and properly. That is, when I say g of f of x means, neglect this g here. When I say f of x, when we are going to get the image of the function, means what values you are going to input here to get the image of the function f. So clearly this is the domain and this is the codomain of the function f. So to get the image of the function f, we know that image of the function f is lied in the codomain. So to get the image of the function f, what values are you are inputting? You are inputting the values of the domain of the function f. So here what you are going to input for this x, that is nothing but g of f of 2. So clearly it is, one thing is clear, that is, when I say GOF function, its domain is nothing but this one, 2, 3, 4 and 5. Now let us see here. When I say g of f of 2, they have given the function value, that is f of 2 is equal to 3. So it becomes g of 3. So g of 3 means the function value g of 3. G of 3 they have only given g of 3 is equal to g of 4 is equal to 7. So g of 3 is equal to what? 7. So clearly when I input the value g for the function g of f of x, that is value when g of f of x is equal to 2, we got the value 7, which is nothing but the set which we are going to get here, that is the codomain of the function g. So clearly now the codomain of this function becomes what? 7, 11 and 15. So now let us find, we got the value of g of f of 2. Now let us find the value of g of f of 3. So g of f of 3 means what happens? G of f of 3. So what is f of 3? F of 3 is 4. So g of 4, g of 4 is what? It is 7. So g of f of 3 is 7. Again similarly g of f of 4. When I say g of f of 4, g of f of 4. So what is f of 4 value? They only defined f of 4 is equal to f of 5 is equal to 5. So g of 5. What is g of 5? It is 11. Similarly g of f of 5, we are going to get g of f of 5. So what is f of 5 here? F of 5 is 5. So g of 5. What is g of 5? It is 11. So we got all the values of g of f. They asked us to find g of f and we have found out. Now I am asking you peoples to work out yourself or think it yourself whether fog exists. Whether fog exists or not. Check it yourself and tell me whether fog exists or not. To this function itself, you need to check yourself and say whether fog exists or not. Suppose if exist means what is its domain and codomain. Suppose if you are saying it is not existing means give me the reason. Give me the reason why it is not existing. So in the next question which I am solving here, they asked us to find GOF and fog, and the function f is defined from set of real numbers to set of real numbers, and g is also defined from set of real numbers to set of real numbers, where f is defined as f of x is defined as cos x and g of x is defined as 3x square. So first thing they asked us to find GOF and fog. First let us find that one and later let us go to the next question what they have asked. So GOF means what? G of f of x. So GOF it is written as g of f of x. So g of x is equal to 3x square, g of t is equal to 3t square. So g of f of x means 3 of f of x square. So 3 of f of x square. So while putting the bracket, concentrate upon the brackets also. So now what is f of x? It is cos x. So what happens? 3 of cos x whole square. Understand it clearly. 3 of cos x whole square. So concentrate upon the brackets also. Next is, this is g of f of x, which is 3 of cos x whole square. Now fog x, they asked us to find both the function combination also. What is fog of x? That is nothing but f of g of x. So f of g of x, f of x is equal to cos x, f of t is equal to cos t. So f of g of x means cos g of x. So cos g of x. So what is g of x? It is 3x square. So cos 3x square. So clearly g of f of x or gof is equal to cos of 3x square. You can observe here clearly 3 cos x whole square is not equal to cos of 3x square. So clearly I can say that fog is not equal to gof. So they ask that itself, check whether fog is equal to gof, or if like this means you can observe here clearly that fog and gof functions both are different, because this is 3 into cos x whole square. Cos x whole square and cos 3x square both are different. So our two combinations are not equal. So one thing in this combination or composition of function is, each questions which we are solving here, it is not like we are solving the numericals or the exercise problems. So each question is giving one or the other concept, or we are learning one or the different concept in each question, so that each concept is carried out for the next concept which we are learning in this relations and functions chapter. So each questions, in each and every question we are learning one of the new concepts here. So let us come to the next question. If we're looking into the question, it might be big, but the thing is, here we are learning one of the concept in the through this question. So what the question is saying is, show that they have defined a function f from the set of real number. They have defined from the set of real number excluding 7 by 5 to the set of real number excluding 3 by 5, and the function is defined as f of x is equal to 3x plus 4 divided by 5x minus 7. And instead of writing this one, they only given here set A and set B, where real numbers excluding 7 by 5, it is nothing but our set B, and real numbers excluding 3 by 5, it is nothing but set A. So f is a function which is defined from set B to set A, and function is defined as f of x is equal to 3x plus 4 divided by 5x minus 7. So why they have excluded here 7 by 5? Because if I take, so here what the values of function f is taking, the functions, the elements from the set or from the domain, that is B. So if I input here 7 by 5, what happens to the denominator? 5 into 7 by 5, 5 get cancelled, 7 minus 7, 0. So anything upon 0 which is not defined, so the function will become undefined when 7 by 5 value is taken. So to which point it is undefined, they have removed that point from the set of real numbers. Similarly for here also. So here function f, it is defined as 3x plus 4 divided by 5x minus 7, and similarly function g is defined from set, that is, this is nothing but set A here, that is r minus 3 by 5 to r minus 7 by 5, it is set B. So function g is defined from set A to B, and it is defined as g of x is equal to 7x plus 4 divided by 5x minus 3. So here also they have excluded 3 by 5. Reason is same. If I input the value for x is equal to 3 by 5, 5 get cancels, 3 minus 3 it is 0. So anything upon 0 which is not defined. So at this point this function will be not defined. So they have removed those or excluded those points where the function will become not defined. So what we need to show in this question, we need to show that fog, what is that? Yes, we need to show that fog is equal to IA and GOF is equal to YB. So looking into IA and IB, the question arises, what is this IA and IB? So in the question itself, they have defined IA of x is equal to x and IB of x is equal to x, which is called as identity function. So identity function means what? We can say it is identical. Identical means same. So identical or identity function means, in the simple word, what I can say is, what you input to the function, you are going to get the same output. So from which set you are inputting, that is represented here. So IA of x means the values which you have inputted for this is from the set A, and you got the value, same value from the set A itself. So G of f of is equal to IB means the values which you are inputted for this function is from the set B, and you are going to get the output as equal to the same function from the set B itself. Similarly for f of g is equal to IA. So identical function or identity function means, the meaning is that itself, what you are inputting, you are going to get the same value as an output. So now let us show that one by one. First thing what we need to show, fog is equal to IA. So now let us consider f of g of x, where let x belongs to which set? Let x belongs to set A. Let x belongs to set A. Why we considered set A? Fog. Fog means the function, the domain of the function. Fog means the domain of the function is the domain of the function g. So what is the domain of the function g? It is A. So we consider the x from the set A. So fog of x, it is nothing but f of g of x. So what is f of x? It is 3x plus 4 divided by 5x minus 7. So fog of g of x means what happens? 3 of g of x plus 4 divided by 5 of g of x minus 7. So you got this value. If I take f of t means 3t plus 4 divided by 5t minus 7. Similarly f of g of x means 3 of g of x plus 4 divided by 5 of g of x minus 7. Now what is g of x? It is 7x plus 4 divided by 5x minus 3. So input that value, 3 of 7x plus 4 divided by 5x minus 3 plus 4. Be careful while solving these type of question. 5 of g of x, again 7x plus 4 divided by 5x minus 3 minus 7. Now solve this one. So how we are going to solve that one? 3 of 7x plus 4 plus 4 of 5x minus 3. I took the LCM. So 5x minus 3 happens to the numerator. In the denominator, 5 of 7x plus 4 minus 7 of 5x minus 3 divided by 5x minus 3, where this get cancels. Now solve this one, which is nothing but 21x plus 12 plus 20x minus 12 divided by 35x plus 20 minus 35x plus, here observe here clearly, minus 7 minus 3. So minus into minus plus, 7 3 is a 21. Now solve this. Minus 12 get cancels. 21x plus 20, it is nothing but 41x divided by 35x get cancels. 20 plus 21, it is 41, which is equal to 41 get cancels x. So we got f of g of x is equal to x. So we got f of g of x is equal to x for all x, where from which set we have inputted here? We have inputted the x from the set A. So for all x belonging to set A. So when we input the value of x and get the same value means such functions are called as identity function. So what happens that one? F of g of x is equal to IA, where A represents from which set we have taken the values of x. So f of g of x is equal to IA. So the first thing I have showed it. Try to show yourself, that is g of x is equal to b. So try to solve it by yourself, that is g of x is equal to IB. So this is for yourself workout. So if you have any doubts while solving this one, you can ask me. So this is how we have defined the identity function. So what it is saying, identity function means which value you are giving as an input, the same value if you get as an output means such functions are called as identity function. So here A represents means from which set you have inputted the values, that represented here with the capital letter A. So this is regarding this question where you learn one of the concept, that is identity function, through this question. So let us come to the next question. So in our previous concept we have came across the concept, that is one function and onto function. Now let us observe how these types of function, that is one and onto functions, are connected to the composition of function. So what the question is saying, show that if f from A to B and g from B to C are 1 then the composition, that is g of x from A to C, is also 1. So they are saying function f which is defined from A to B, this function is 1. And they are also saying function g from B to C they have defined, and this function is also 1. So with these two functions we can compose the function g of f, where domain is A and codomain is C, and we need to show that this function is also 1 function. So clearly we know that if f is a 1 function means if f of x1 is equal to f of x2, this implies x1 is equal to x2. This is what the, if a function is 1 means this is what it is going to be said. So now let us go to prove the function g of f of x is a 1 function. The same process or the same algorithm is used even for the composition of a function to prove it 1 function. So to prove g of f has a 1 function, let us consider x1 and x2 be two different numbers. x1 and x2 be the two different numbers. So what we are assuming first, if or suppose g of f of x1 is equal to g of f of x2. As usual, what we used to do in the beginning while we are studied only with the one function, the same thing. First we are taking these two functions as equal, same, or assuming two images equal for the same, for two different elements, and finally we are saying that two elements are same. So here also for this function, GOF function, the image of GOF functions we are assuming it as equal. So g of f of x means what? It is nothing but g of f of x1. So this is also equal to g of f of x2. So now we know that g is a 1 function. So g is a 1 function means what does that implies? If g of x1 is equal to g of x2 means, if g of x1 is equal to g of x2 means x1 is equal to x2. Here in the place of x1 we are having f of x1, and in the place of x2 we are having f of x2. So g of x1 is equal to g of x2 means x1 is equal to x2, because the function g is 1. So if g is 1 means g of x1 is equal to g of x2 implies what? x1 is equal to x2. Here x1 means f of x1 in this one, x2 means f of x2 here. Because why this one? G of f of x1 is equal to g of x2 implies f of x1 is equal to f of x2. What is the reason? The reason is g is 1 function. Similarly, f is also 1 function. Since f is 1 function, if two image of the two elements are same means what happens? Those two elements are equal because f is also 1 1 function. So from what we have started considering two different elements and assuming the image of those two elements are same. So by starting with the image of those two elements are same, we came up with those two elements are not different, they are same thing. So the same algorithm for 1 1 holds. Therefore GOF is a 1 1 function. So I'll say it once again, brief it once again. So as usual, GOF function means what we are saying to prove it as a 1 1 function, same algorithm it implies. First we are taking the image of two different elements as same and finally concluding that two elements are not different, they are same elements. So here the function is GOF. So g of f of x1 is equal to g of f of x2. So that is nothing but g of f of x1 is equal to g of f of x2. So since g is a 1 1 function, it's if two what can I say, if the two images of the function g are same means then the two elements are same. That is what the function 1 1 is saying. So g of f of x1 and g of f of x2 means this is nothing but image of the function g. So what will be the elements of that function? That is nothing but f of x1 and f of x2. So since g is 1 1, what happens from this step to this step? This implies f of x1 is equal to f of x2. Now again they have said f is also 1 1 function. Since f is also 1 1 function, what does that implies? x1 is equal to x2. So we started with two different images and conclude with the two different elements. So that implies that two are not different, they are one and the same. Therefore the function is 1 1 function. So this is how we have proved when two functions are 1 1 function means then the composition is also a 1 1 function. Similar like 1 1 function, they are asking regarding the onto also. That is, if two functions are onto means then the composition of that function GOF is also an onto function. So what they are saying, f from a to b, it is an onto function. So what does the definition or the onto function is saying? If f from a to b is an onto means, suppose if I take the elements in the set A has x and elements in the set B has y and elements in the set C has z means, suppose if I am talking about an onto function from f from a to b means, what does that says? If function from f from a to b is an onto means, for all y which is belonging to set B, there exist x which is belonging to set A such that f of x is equal to y. That means what and all the elements which are present in the set B, all those elements are the image of one or the other element which are present in the set B. That is what f from a to b onto implies. Similarly, they are saying function g from b to c is also an onto function. So what does that implies? If b to c is also an onto means, for all z which is belonging to set C, there exist y which is belonging to set B such that g of y is equal to z. So now by combining, what does here saying? Suppose you can imagine with the pictorial representation also, a b c, from a to b function f, from b to c function g. So for every element which are present in the set B, all these elements are occupied. So for all y which is belonging to set B, there exists a x which is belonging to set A such that f of x is equal to y. So for all these elements, there exist one or the other elements present in the set A. Similarly, they are said G also onto function. So what does that saying? For all elements which are belonging to the set C, all those elements are occupied by one or the other elements which are present in the set B. So here also all elements are occupied means all these elements are the image of one or the elements present in the set B, and all these elements are the image of one or the elements in the set A. Now combining all these two, all these means all the two statements, we can write as, for Goff function, g of f of x, that is nothing but g of f of x, where f of x is nothing but y, that is g of y, which is nothing but z. So g of f of x is equal to z. So what does the statement is saying? G of f of x is equal to z means for all z which is belonging to the set C, there exists a x which is belonging to set A such that g of f of x is equal to z. Therefore Goff is also an onto function. So what we have did here, this is by combining the two statements of the two onto statement from the given data. So what it is saying now, that is g of f of x is equal to z. What does that implies here? For all, that is similarly here, for all z which is belonging to set C, there exists a x which is belonging to set A such that g of f of x is equal to z. So that implies what? The function g of f of x is an onto function. So this is how they have combined the composition of two or more functions to one and onto function. So here in these two questions we will understand the how we can say the composition of a function is 1 or onto when they have defined the characters of two functions. That is, if f is 1 and g is 1 means composition is also 1. If both are onto means the composition is also onto. So with the previous two question, we can note one of the important concept, that is, if both functions are 1 means then the composition Goff is also 1. If both functions are onto means then the composition is also onto. Now the ulta of this concept, that is, suppose if Goff is 1 means whether both f and g are 1. So we need to check this one, as well as they are asking suppose if Goff is onto means whether both f and g are onto. So let us check with one of the random example. That is, I am taking the set 2 set, that is set A from what is 1, 2, 3 and 4, and set B has 1, 2, 3, 4, 5. Suppose if I am taking the set A and set B has like this, and the function it is defined, f is defined from these two set. The function is defined as f of x is equal to x. So f of x is equal to x means what happens? If I take value of x is equal to 1, f of x is also 1. Suppose if I take x is equal to 2, f of x is 2. X is equal to 3 means f of x is 3. X is equal to 4 means f of x is 4. So this is the function, and I'll define another function g of x has also equal to x for g of x is equal to x for x is equal to 1, 2, 3, and g of 4 and g of 5 I'll define it as equal to 4. So what happens, our set C, it will be 1, 2, 3, 4. How it is defined? G of x is equal to x itself. For what and all? The function g of x is equal to x when the value x is equal to 1, 2, 3. So when x is 1, g of x is 1. When x is 2, g of x is 2. When x is 3, g of x is 3. So for 4 it is 4 itself. For 5 it is 5 itself. Now with this example, let us see whether g of f is 1 or not. Clearly, when g of f of 1 means what happens? G of f of 1, f of 1 is 1. So g of 1 is 1. So f of 1 is 1. G of f of 1 is 1. So what happens to g of f of 2? F of 2. F of 2 means 2 and g of 2 is 2. So 2. G of f of 3 means f of 3 is 3 and g of 3 is 3. What is g of f of 4? F of 4 is 4 and g of 4 is 4. So all the elements from the domain, that is from the set A, it is occupied, and each elements are having unique images. So one and only one images. So clearly Goff is what? 1 function. Clearly Goff is a 1 function. By looking into the mapping itself, I can say F is 1 function because all the elements of the set A is occupied and all the elements are having unique or one and only one image in the set B. But G is not 1 but G function is not 1 because both element 4 and 5 are having the same image. What does the function of 1 is saying? Each element of the set should have one and only one image, but here 4 and 5 are having the same image, so G is not a 1 function. So by what we can say to this statement, suppose if composition is 1 function means it does not imply F and G should be also the 1 function. So both 1 function, it is not at all possible. It is means not at all possible means it implies it is not the must and should condition that F and G should be also 1. If G of F is 1 means here our unique, that is F and G, it need not be 1 function. So now similarly let us check for onto condition also. For that I will define the function. Let it be set A, B and C. Let the element of set A be 1, 2, 3, 4 and B be 1, 2, 3, 4, 5, and let F be the function from A to B, and it is defined as f of x is equal to x. So what happens when f of x is equal to x? 1 is the image of 1, so 2 is the image of 2, 3 when we take value 3, f of 3 is 3, f of 4 is 4, and let G be the function from B to C. And there is, I am not defining any particular function for G. I will define it as G of 1 is equal to 1, G of 2 is equal to 2, and G of 3 is equal to G of 4 is equal to G of 5 is equal to 3. So what happens to the elements of set C? It is 1, 2, 3. So G of 1 is 1, G of 2 is 2, and for G of 3, G of 4, G of 5, it is 3. Now let us check first whether Goff is onto or not. So clearly when I say Goff means the function is defined from set A to set C. Goff is defined from set A to set C. So all the elements of the set C are occupied. You can check it. If I take G of f of 1 means what happens? G of f of 1. So f of 1 is 1 and G of 1 is 1. So G of f of 2 means f of 2 is 2 and G of 2 is 2, and G of f of 3 means what happens? F of 3 is 3 and G of 3 is again 3, and G of f of 4 means f of 4 is 4 and G of 4 is again 3. So you can see here all the elements in the codomain of a function G of f, that is C. All the elements are occupied by one or the other elements, that is 1, 2, 3. All the 3 elements are image of one of the element of the elements present in the domain of the function G of f. So here all the elements are occupied, therefore Goff is an onto function. It is an onto function. Clearly here function G is an onto function because all the elements, G is a function defined from B to C, so codomain is C here, so all the elements of the codomains are occupied, therefore G is an onto function. But F, function which is defined from A to B, it is not an onto function because here 5 is not at all the image of any of the element present in the set A. Therefore function F is not an onto function. Therefore what we can say, suppose if Goff is an onto function means it is not necessary that F and G should be also an onto function. With these two random example or these two random note, one thing which we can note or a proved result is if Goff is Goff is 1 function means Goff is 1 function means then here Goff is 1 function means clearly f is also a 1 function. Goff is 1 means function f is also what? 1 function. You can see here. And again, suppose if Goff is an onto means our G is also onto. This is Pakka result, or what we can say, derived result. This result you might be helpful for some of the MCQ questions or some of the questions when you are solving based upon the composition of a function. So what it says means, suppose if composition of a function is 1 means, then f is also 1 function. Suppose composition of a function is onto means G is also onto function. So this is what the derived result is saying based upon the composition of a function. So these are the concepts which we have studied today upon the composition of function. So go through each and concept carefully. Understand when we talk about the composition of a function, what will become the domain and codomain of a given composition of a function, which is very important to understand. So understand that concept, guys. So here, while explaining this relations and functions, it is one-way communication for me, so I can't understand whether you peoples are following or not properly, or whether you peoples have doubt regarding any of the concept. Suppose if you didn't get any of the concept, or if you are not following means, please let me know which concept you are not following or which concept you are not getting. I will try to explain it in some other manner so that you can understand it in the easier way. So the response regarding if you are understanding or not, it is matters a lot, because all these concepts which are coming in the next are connected to one another, which is one of the huge concept in your function relations and functions concept. That's why I'm asking. So if you didn't get any of the concept means, you can ask me at any time. So this is regarding the composition of a functions. Thank you, guys.